Hi, for this video, I just want to do another example of graphing a piecewise function. This one does have 3 pieces to it. Again, if you have less than or greater than, you will always use an open circle to start your array segment. If it's less than or equal to or greater than or equal to, then you would fill it in. The open circle just means that it's everything up next to it, but not including that point. The closed circle means that it does include that point. If you have overlapping points, you do have to make sure that not both of them are filled in, because then it's no longer a function. In order to be a function, it can only fit into one of the equations. So with this, let's start with our first graph. For the first graph, I'm going to graph this one. This is, remember, our starting point. So it's telling us that we're looking for all values that are less than -1. So everything that is to the left of -1, I'm going to plug into the quadratic equation x squared. So we always start at whatever is given to us. So for this one, we're going to have array. The second piece will be a segment because it does have 2 endpoints. So you would just plug in both endpoints. And then the third one will be another array. So if we look at this, if I plug in -1 into the x squared equation, -1 squared gives me +1. So this would be my starting point. And I always want to make sure that I ask myself, is it going to be open or closed? In this case, it would be an open circle, so it's everything right up next to it, but not including that point. And then if I go to -2 when I square, I would get 1, 2, 3, 4. And I could continue in that direction. 9 would go off of here because -3 squared would be +9. So for this one, I'm going to have a quadratic that looks like this going to the left. Okay, so this is a quadratic going in one direction. And then at that point, I have a jump from -1 to 2. So for this graph, what we're going to do is we're going to look at -1 and 2. Because this does not have an x in it, that's considered a constant function. That means that y is going to be 5 from everything from -1 up till 2, but not including 2. So this one does include -1. So if I go up 1, 2, 3, 4, 5, okay, it does include -1, so I would fill this one in. And then all the way to 2, 1, 2, this is going to stay the same thing. It's a constant function. So I have a hole. I use an open circle at 2 because it does not include it since there's not a line underneath here. Okay, so anytime there's an x, there is no x term in here, that's a constant function. That means that y is constantly 5. And then our last piece of the puzzle, so our last piece of the puzzle here, it's for all values that are greater than 2. So I would start at this point, start at 2. So I would plug that in. 2 times 2 is 4. And 4 minus 4 gives me 0. So I would start at 2 and my output is 0. So if you need to write it down, you can. But when I plug in 2 into here, 4 minus 4 gives me 0. If I go to the next point, and again, I used an open circle here, okay? It's very, very important to make sure you know whether to fill it in or not. For this one, I would then go to the next point, which is 3. And 3 times 2 would give me 6 minus 4 would give me 2 as my output. Or I could use a slope, up 2 over 1, up 2 over 1. Since this is a linear equation, I could continue that forever and ever. So this is going to go this way. So we have a piece that is array with a straight line because this is a piece of a line. We have a line segment, and then we have a piece of a quadratic. So for this, our domain and our range are a little bit more difficult for this one. Remember that our domain is all of our x values. Well, all values up until -1 are included here. And then we go up to -1, it's still included. But if you notice, both of these have a hole. Since both of these have a hole, that's telling us that 1 is excluded in all graphs. So that means that all values of x, so if I put it in set notation, I could say all values of x, except for x equal 1. So this would be all real numbers except x equals 1. In interval notation, what you have to do is you would start from negative infinity. Everywhere it's hitting something on this graph, then it jumps to this graph, and then we have a hole, so we have a break. So if you wanted to put the domain in interval notation, we would do negative infinity up until 1, where we have a break, and we would put a parenthesis because it doesn't include it. And then we would say from 1 to positive infinity, because if I look at this one, it continues all the way to the right. Okay, so depending upon which course you're in and how you're supposed to write it, this would be set notation. And this would be interval notation. It can be written both ways depending upon the course that you are in. Okay, and then our range is all of our y values. So if we look at this, we don't start hitting something until we get to here, and it doesn't hit at 0, it starts at 0, and then it hits everywhere else. So everything from 0 to 1 is included on this one, and then it's on either the blue or the yellow continuing all the way up, since both continue in both directions. So for this one, it starts at 0, but it's not including 0. I guess I should start with set notation since I started with set notation on the last one. So let me start with set notation. With set notation, we would say it's all y values such that y is greater than 0. So this would be set notation. Okay, and then in interval notation, we would say that it's from 0, not including it, so we would use a parenthesis, so it's all values getting close to 0. So like 0.001, 0.002, etc. And then it would continue all the way to positive infinity. As always, thanks for watching. If you have any questions, please let me know.